so we're still working on our first example where we have these bean plants. We want to take these 10 numbers, put them into Minitab, and produce a confidence interval for the mean bean production. So how are we going to do that? Well, let's just flip over to Minitab and type our numbers in. Okay, so we flip over to Minitab. And I'm just going to put all the numbers down in this table. So you could go in a row. I think that it works. My standard is to put things in columns, and it seems like Minitab defaults to columns too. So let's just type the 10 numbers in into a column here. There's probably a clever way that I could copy and paste it over from my Word document. But then it would be arranged as a row, and I'm not sure it could convert the spaces to different cells, and then I'd have to transpose everything if I wanted columns. So I'll just type in all 10. Okay, so there's my 10 numbers. I don't think there's any typos. So how do we run our test then? We're going to go stat, basic statistics. This is what we did when we were analyzing one proportion. We're not doing one proportion anymore. Proportion was for categorical variables. Now we have quantitative variables. What I'd like to see would be one mean. That would sort of make sense because we're estimating one mean. That doesn't appear here. We're actually up in this section where they say sample. So there's one sample Z and one sample T. We have to use one sample T. The difference between these is you can use one sample Z if you know the true standard deviation for the population. Okay, we don't know the actual standard deviation for these bean plants. We only know the standard deviation for our 10 in our sample. What that does is we're not actually going to be basing our computations off the normal distribution anymore. We're going to be basing them off of a slightly wider bell called the t distribution. Now, you don't have to understand how the t distribution works. Just understand that because our standard deviation that we're using is a bit of a guess, it's not the real standard deviation. It means we have to use this slightly worse bell curve, and all of our guesses are going to be our confidence interval has to be a little wider because we know that our guesses are slightly less accurate. So that's why we always use the t. So this one sample Z, we're never going to use that in this class. We're going to use one sample t, two sample t, paired t. We're going to use these t ones. We never use the Z one because in our examples, we never know that population standard deviation. So one sample t. Okay, so this C1 wasn't there. I was practicing ahead of time. So we have one or more samples in each column. See, it's set up for columns. So we have to put things in columns. And then there's summarized data. Summarized data means you know the sample mean and standard deviation already. We don't know the summarized data. We have the raw data that I typed into this column. So let's type in this box. It brings up my list of columns that have numbers. We'll select the column that has the data that we typed in and hit select, brings it over here. We have options. I want to find a 95% confidence interval. That's good. What about graphs? We could produce a histogram if we wanted to. And then there's some other stuff like box plot, individual value plot. If you wanted a picture interpretation of these numbers, then you could make a graph. Maybe we'll try that later when we have more than just 10 numbers. And let's just hit OK. We are going to do hypothesis tests later, but we won't bother with that right. Excuse me. We won't bother with that right now. So we'll hit OK, see what we get. All right, so there's 10 plants in our sample. The mean for our sample was 1.54. So I could have done that before, but I didn't bother adding those numbers up in my calculator. The standard deviation for our sample, 0.412. So SE, that's the standard error. So that's if you take this 0.412 and divide it by the square root of 10, right? And that's our standard error number. And then finally, this is the thing that we really want, the 95% confidence interval for mu, the population mean, is 1.246 to 1.834. So let me just copy that over into my Word document. I I know that I'm not screen sharing my Word document right now, so you can't see this, but that's fine. I'm just typing in the answer we got to save for later. Okay, so what we're saying is that we believe with 95% confidence, there's always that 5% chance we're wrong, but 95% chance that the mean of all bean plants that we could grow is somewhere between 1.246 and 1.834. Now, that doesn't mean that 95% of all bean plants are in that range. You know, we had plenty of bean plants that were over 2 and under, like we had that 0.6 plant, and then we had a bunch that were in the 2s. Okay, it doesn't mean that 95% of beans are in that range. It means that we think that the mean of all bean plants is in that range. When you balance out the highs and the lows and take the average, we think that that average is somewhere between 1.246 and 1.834. And the 95% just means that there's a 5% chance that we're wrong, and it's actually either lower than 1.246 or higher than 1.834. So that's an easy mistake to make, to think that 95% of all plants are in that range, but it's not. That's not the case. It means that we think that it's 95% likely that the mean is in that range. Okay, so that's our answer to the first example. Let's stop the video, and I have 2 more examples for today where we just sort of do more of the same.